to tell you a little bit about the life history of a star for a moment to show you how you're connected to the night sky. This is, you can't read this, but I can, which is what matters. Stars burn, and the rate at which they burn depends upon how big they are. Our sun will last about 10 billion years. It's 4.5 billion years old now. It's halfway through its life. 10 billion, so it has another 5 billion years left. Which, by the way, reminds me of actually the only real cosmology joke I know, so I'll tell it to you. So someone like me is talking to a group of people like you on a Sunday, and he says, you know, the sun is going to burn only for 5 billion more years. And someone in the audience goes, did you say 5 million years? And the speaker says, no, 5 billion years. And the guy goes, whew, okay. So when a star 10 times the mass of our sun, however, is burning, it burns much faster, and it lives not 10 billion years, but only 10 million years, which is important. It's really important for us that big stars have short lives. And what happens when they do that? Well, stars are burning hydrogen fuel, just like our nuclear bomb did, turning it into helium. And when they do, they emit, each time some hydrogen nuclei come together to form helium, they emit over 1 million times more energy than you would get by lighting a match. Well, the biggest bang for your buck, as my friends in Los Alamos say. And that means, and that's the process by which stars burn. And since I'm in London, it also reminds me of another important story, I guess, is that people didn't know how stars burned. What was the power source behind stars was a big problem. How long can they last? And one of the first calculations of how long stars should last was done by actually a German doctor, which is amazing that he did a calculation, in the 18th century. And he said, well, if the sun is a lump of coal, and you knew the mass of the sun, it's easy to determine the mass of the sun, 1 million times the mass of the earth, how long would it be able to burn? And the brightness it's burning now. And the answer was remarkable. When you worked out, it was 10,000 years, which was perfectly biblical. It was exactly right. But of course, we later learned that the Earth was actually older, and it was a big problem. How could you have a process that could cause an object to burn for much longer? And two physicists, Lord Kelvin here and Helmholtz in Germany, did an independent calculation. They said, well, maybe as stuff collapses, gravity causes it to collapse and emit energy, and maybe gravity is powering a star. And they worked it out, and they found out gravity could power a star for not 10,000 years, but about 100 million years, which was great. But even then, we knew the Earth was older than 100 million years old. We knew it was billions of years old, and it was a problem. And in 1929, Sir Arthur Stanley Eddington, a very well-known British scientist and astronomer, wrote a book on the internal constitution of the stars, and he said, there has to be some new energy process, some new physics working inside the star. And everyone's, they scoffed at that idea because the sun isn't that hot. It's only 1 million degrees. And 10 million degrees in its center, which is not that hot. I live in Phoenix, and it's not really that hot. And it's hot enough that you could recreate those conditions in the laboratory, even then in the 1920s, and people thought they understood all the physics at 10 million degrees. And he said there had to be something new, and everyone said no. And one of my favorite bits of scientific literature, if you read that book, it says, for those who don't think the interior of the sun is hot enough for new physical processes, go and find a hotter place. That was British for go to hell, Satan. In any case, we've always learned in the 1940s that there was a process that was a new process, and that was nuclear reactions, causing hydrogen to burn to helium. And as I say, in our sun, that will go on for 10 billion years. But in a big star, it only goes on for 10 million years. So all the hydrogen burns into helium in 10 million years. What happens then? The flame goes out, if you wish, not quite, but almost. And then gravity starts to work, contracting the star. But then it gets hotter and hotter, and eventually it turns out that helium can burn to carbon. It's a much less efficient process. It's kind of miraculous and it works. But all of the hydrogen burns to helium in 10 million years. But because the sun is hotter and it's less efficient, to keep the energy production up, all of the helium burns to carbon in 1 million years. Then what happens? Well, the carbon's there. Okay? Again, the star starts to collapse because there's no more fuel. But then it heats up. Carbon starts to burn. Carbon starts to burn to form neon and nitrogen. And all of the carbon in the star burns in 100,000 years. Because again, it's less efficient a process. And you get to oxygen. And oxygen again starts to burn eventually, and all of the oxygen burns to silicon in 10,000 years. Because it's getting hotter and hotter and hotter, less efficient, and then when all of the oxygen is burned to silicon, you're in the last day in the life of a star. Because remarkably, it is so hot at that point that all of the silicon in the center of the star, many thousands of times the mass of the Earth, burns to form iron in one day. And at that point, it's rapidly burning and struggling for existence, because once it's burned to form iron, it's on its last death throes. Because iron can't burn to form anything. Iron is the most tightly bound nucleus in nature, and so once that happens, there's no more fuel. And it's kind of like Wile E. Coyote, when I don't know if you see it, it was a cartoon that I saw in the United States called The Roadrunner. He runs off the cliff and then suddenly realizes there's no cliff there and he falls down. And that's exactly what happens to the star. When all the silicon is burned to iron, suddenly the star realizes there's no place left to go. And that interior of the star, which has been held up by the pressure of nuclear burning, collapses. And that whole collapse happens in 1 second. And when it happens then, it spews out, there's a shock wave, and the shock wave, like an onion, spews out all of the elements that were created during the life history of a star. The carbon, the nitrogen, the oxygen, the iron. And that's vitally important, because every atom in your body was once inside a star that exploded. In fact, as I said, and I think the quote is in there, the atoms in your left hand probably came from a different star than your right hand, because 200 million stars have exploded to create the elements that make up your body. Because in the Big Bang, only hydrogen, helium, and lithium were created. That's not important. Well, lithium may be important for some people in this room, but but carbon, nitrogen, oxygen, all those other things are the stuff that we depend upon. And those weren't created at the beginning of the universe. The only place they were created were in the nuclear furnaces at the center of stars. And the only way they could get into your body was if the stars were kind enough to explode. So as I said, and I threw it in a throwaway line, but it's become a big line. Forget Jesus. Stars died so you'd be born today. Okay? And it's true. You are stardust. It is literally the most poetic thing I know about in all of science. You are star children. You would not be here. Just think about that. Every atom in your body has experienced, maybe more than once, the most violent explosion in the universe. They had to, because they couldn't have gotten into your bodies otherwise. And 5 billion years ago, a supernova exploded in our region of the galaxy, compressing gas, triggering the formation of our sun. And it was those elements that came from that supernova explosion, mixing with the gas in the solar neighborhood, that produced everything we see in this room, and all of the rocky planets and everything. You are connected to the cosmos in an intimate way, and your atoms have been around for billions of years, changing their form until 5 billion years ago. They came together in the current form they have, and they haven't changed since then. And they're in your body. So that was the first cosmic connection. You were connected to the universe by your atoms.